So, you know that you will need $40,000 for your child's education in 18 years. If you've got an account that earns 4% compounded quarterly, how much will you need to deposit now to reach your goal? Now, note there's a couple important things to note about this question. First is we're talking about a deposit now, which means we're only making one deposit. And that's what clues us in that this is a compound interest problem and not something like an annuity problem. So let's see what we know. Do we know the initial amount that's going to be in the account? We really don't know that here. This is our unknown. But hopefully we know some other stuff. Do we know the interest rate? Yes, it is 4%. Do we know the number of compounds in a year? Well, we're compounding quarterly, and so there will be 4 compounds in a year. Do we know the number of years that we're interested in? Well, we're talking about $40,000 in 18 years, so it looks like we're talking about 18 years. And where does this 40,000 come into it? Well, the 40,000 is how much we want to have in 18 years, and so the amount in our account in 18 years should be 40,000. So if we think about our equation, 1 plus r over k to the k times n here, we know values for rk, kn, and pn as long as we let n equal 18, right? So if we go ahead and say, okay, let's let n be 18, now we know values for everything except for p0. So let's go ahead and fill in the rest of those values. So p18 is 40,000. p0 is unknown. R is 0.04, 4%, and K is 4, 4 times 18. All right, so there we go. We're all set up now. All we need to do is solve for P0. And so to do that, we're going to start by simplifying some stuff down. So we'll go ahead and start by saying it's your 0.04 over 4 is 0.01, and 4 times 18 is 72. And now I'm going to pull out my calculator and evaluate this part. So pulling out my calculator, I'm going to figure out 1 plus 0.01 raised to the power of 72 is 2.0471 about. Now, when we're calculating these things, it's very, very, very highly advisable to keep at least 3 significant digits. So at least 3 decimal places. In this case, I'm going to go ahead and keep 4 just to be a little safer. If we can keep more, all the better. The more we keep, the more accurate our answer will be. So our last step to solving is going to be to divide. So we're going to go ahead and divide and get P0 equals 40,000 divided by 2.0471. And that gives us an answer of about $19,539.84. So in other words, if you need to have $40,000 in 18 years and your account earns this rate, you would need to deposit about $19,500 now in order to reach that goal.